Here is a portrait of inventor of Bayesian statistics, Thomas Bayes, the Reverend Thomas Bayes, because he was a ordained pastor. Before I get into more technical details of Bayesian statistics, I'd like to provide a brief history of the emergence, the depopularization and popularization, repopularization, reemergence of Bayesian statistics. Okay. Thomas Bayes lived in 1701 to 1761. He was the son of first 6 ordained nonconformist Puritan Christian ministers, Joshua Bayes. A little bit of historical background, why we had these nonconformist ministers. Because in the mid and early 16th century, England had Henry VIII, as king, and because of legal issues with his divorce and kind of battle with Roman Catholic Church, because of that divorce, because Henry VIII wanted his divorce to be legitimate, right? And it looked like that legit recognition from Roman Catholic Church was impossible. So he decided to create his own church, Church of England, to be separate from Roman Catholic. And that transpired in 1534. And that left some ministers and Christians unhappy, okay? So some of the Christians and Puritan Christians and, to become descending on nonconformist Christians, they didn't conform to the governance of the Church of England and were persecuted, to a great extent. And Thomas Bayes was also a nonconformist minister himself. During his 40s, probably because of religious reasons, Bayes' interest in mathematics and theology began to tightly intertwine. Thomas Bayes published 2 papers during his lifetime, and one of them was religious, and the other one was mathematical. Bayes' only mathematical publication during his lifetime was a piece defending and explaining Newton's calculus. And some historians argue that because of that, he was inducted to the Royal Society. But his contribution later on, from today's perspective, was strong enough to get him inducted into Hall of Fame of prominent scientists. So that paper was titled Introduction to the Doctrine of Fluxions, in today's term is derivative, in defense of mathematicians against objections of the author of analyst so far as they are designed to affect their general methods of reasoning. So this is not uncommon, long title for a scientific paper, even from today's perspective and standards. Well, the paper that really got Bayesian inference started was published posthumously by his Thomas Bayes' intellectual executor, Richard Price, as a rebuttal of a paper published by David Hume, titled Of Miracles in 1748. In that paper, David Hume challenged the fundamentals of church and Christianity. Back then, and here we know that Thomas Bayes was an amateur mathematician, right? At least from then's standards, of course, not today's view. Back then, many scientists believed that natural laws did indeed prove the existence of God. So both Price and Bayes were Christians, and they were not happy. And according to historians of statistics and mathematics and science, they collected very strong evidence that Price very likely used Bayes' paper manuscript to challenge, to refute David Hume's views expressed in Of Miracles. Okay. So basically what happened was that Thomas Bayes scribbled down some of his ideas, related to basically today called Bayes' theorem, and Price revised those texts, and probably some historians believe that he, at his kind of bit flavor, not fundamentally revised Bayes' manuscript, but at his wording and his taste and his flavor. So the finalized paper was titled "An Essay Toward Solving a Problem in the Doctrine of Chances." It was published posthumously by Thomas Bayes' friend Richard Price, who is the intellectual executor of Thomas Bayes. And the paper was read to the Royal Society in 1763 and published on Philosophical Transaction, I believe, in 1764. So let's talk a little bit about what's written in that paper. And the main idea today's statisticians believe to be related to Bayes' theorem and the whole business of Bayesian inference appears in section 2 when Thomas Bayes or his co-author Richard Price describe a thought experiment. So here is the kind of original publication from that paper. Okay, and this is this imagined flat table that Bayes and Price describe in this section for their thought experiment. So here is this thought experiment that many believe to be the origin of Bayes' theorem or Bayes' rule. So here is this thought experiment. An experimenter supposedly throws balls on a level table, and so toss an imaginary ball with the experimenter's back turned, not knowing where the first ball lands. Okay, and that experimenter gonna throw a second ball, and gets reported whether it lands to the left or right of the first ball. Then this experiment continues, okay, with numerous throws and thereby updated information. With their derivation, Bayes and primarily Bayes, and I believe that one can deduce the landing location of the first ball. So this uses induction, right, to figure out, like the first principle or what happened originally, right? Originally, okay. So that is the origin of Bayes' theorem and the Bayesian inference. And we can see that in that paper, there's no formal formulation of Bayes' theorem, nor is there any very clear formulation of Bayesian inference. So some scholars argue that, well, whether it is, Bayes, Thomas Bayes, as or to be the inventor of Bayesian inference, that's arguable. And in 1774, Laplace, a French mathematician, derived Bayes' theorem independently, not being aware of Bayes' work. Laplace clearly states that the probability of a cause given the event is proportional to the probability of the event given its cause. So that is literally the textual rendition of Bayes' theorem, equivalent almost. And later on, Laplace also put down a mathematical equation exactly equivalent of Bayes' theorem. So the Bayesian version of Laplace inference was widely taught in the 1800s, but later on was replaced with frequentist inference after R.A. Fisher and Jerzy Newman proposed their frequentist version of non-hypothesis and statistical significance testing, that framework, frequentist framework. It was the publication by Harold Jeffreys in 1930s and later on 1950s and 60s, revived Bayesian inference, especially the publication of theory of probabilities in 1938. So here is a couple, major time points in the timeline of the revival of Bayesian inference. Richard T. Cox, again a physicist, and know that Harold Jeffrey was a physicist, geophysicist. Richard Cox was also a physicist. Showed that Bayesian inference is logically consistent. Also, kind of wind the clock backward a little bit. Andrei Markov, a Russian mathematician, a great Russian mathematician in 1906, introduced Markov chains, laying the foundation work, computational foundation work that made MCMC possible, and estimation, Bayesian estimation possible later on. Stanislaw Uland John van Neumann, this polymath, and Nicholas Metropolis, 1949, co-introduced Monte Carlo. So then we can combine these two to have this MCMC Monte Carlo. Metropolis and others introduced MCMC in 1953. The Metropolis algorithm was generalized to Metropolis-Hastings algorithm by W.K. Hastings in 1970. And also Valentin Fedorovich Turchin discovered Gibbs sampler in 1971. Know that Metropolis-Hastings is the generalized version of Gibbs sampler. Gibbs sampler was introduced to statistics in 1990, and Bucks began its development in 1989. That's when MCMC, accordingly, Bayesian statistics took off as a serious challenger of frequentist statistics.